Tides around the world. Tides are the rhythmic and regular movements of Earth's water masses caused by the gravitational forces exerted by the Moon and the Sun, as well as Earth's own movements. These phenomena are observed in oceans, seas, lakes, and even large rivers. Tides are not merely about the rise and fall of water, they also have significant impacts on ecosystems, maritime activities, energy production, and coastal communities. Scientific basis of tides. Tides are primarily caused by gravitational forces. Both the Moon and the Sun's gravity affect the water masses on Earth. Since the Moon is closer to Earth, it has a greater influence on tide formation. The main reason for tides is the gravitational pull of the Moon on Earth's water bodies. As the Moon orbits the Earth, it pulls water toward itself, causing water levels to rise in the direction of the Moon. This rise in water is called high tide or flood tide. On the opposite side of the Earth, the water level lowers, leading to what is known as low tide or ebb tide. Although the Moon is the primary source of tides, the Sun also plays a significant role in this process. Despite being much farther away, the Sun's massive size means its gravitational pull still affects tides. When the Moon and the Sun are aligned, during the new moon and full moon, the strongest tides, called spring tides, occur. Conversely, when the Moon and Sun are at right angles to each other, weaker tides, known as neap tides, form. Tide cycle and types. Tides rise and fall twice a day around the world. This tidal cycle completes approximately every 24 hours and 50 minutes. This extra time is due to the Moon's daily progression as it orbits the Earth, requiring more time for the same alignment. The types of tides vary depending on geography and ocean dynamics. The primary types of tides are semidiurnal tides. These tides feature 2 high and 2 low tides every day. They are the most common type of tide and occur in many places, such as along the western Atlantic coasts. Diurnal tides. These tides only have 1 high and 1 low tide per day. They are less common and typically occur in places like the Black Sea and the Gulf of Mexico. Mixed tides. These are characterized by 2 high tides and 2 low tides of unequal height each day. This type of tide is common along the western coasts of the Pacific Ocean. Effects of tides. Tides are critical for maintaining natural balance and regulating coastal ecosystems. They also have significant impacts on human activities. Ecosystem impacts. Tidal movements support many marine and coastal ecosystems. Tides bring nutrients to coastal areas, supporting plant and animal life. For example, mangrove forests thrive due to the nutrients brought by tidal flows. Birds and other marine animals also benefit from the food chains that tides help create. Impacts on coastal communities. Tides influence the lives of people living in coastal communities. During high tides, coastal areas can experience flooding, threatening residential areas and farmland. Therefore, predicting and managing tidal movements is crucial for coastal safety. Maritime navigation and transportation. Tides play a key role in maritime activities. During high tides, large ships can dock more easily at ports, while low tides can create shallow waters, restricting sea traffic. For small harbors and fishing boats, accurate tidal predictions are vital for safety and efficiency. Energy production. Tidal energy is gaining attention as a renewable energy source. The vertical movement of water during tides can be harnessed for energy production. Tidal power plants convert this motion into electricity using turbines. Countries like France, Canada, and the United Kingdom are increasingly investing in tidal energy production. This method is seen as a potential solution to reduce dependence on fossil fuels. Global distribution of tides. The height and frequency of tides vary greatly across the world, depending on factors like ocean depth, coastal structure, and Earth's rotation. For instance, the Bay of Fundy in Canada experiences the highest tides in the world, where tidal heights can reach up to 16 meters. In contrast, in enclosed seas like the Mediterranean, tides are much weaker, with only a few centimeters of difference in water levels. Tidal strength is also affected by coastal geography. Narrow and shallow bays tend to experience more pronounced tidal movements, while open and deep oceans show more balanced tidal flows. Similarly, ocean currents and winds in different parts of the world can influence the size and strength of tides. Climate change and tides. Climate change can complicate tidal patterns and their effects on coastal areas. Rising sea levels due to global warming can make tides stronger and more impactful. This can lead to more frequent coastal flooding, posing a serious threat to low-lying coastal settlements. Melting glacier and rising ocean temperatures can also affect tidal dynamics. As oceans expand and sea levels rise, tides can become more pronounced over larger areas. Therefore, it is crucial to monitor tidal movements in conjunction with climate change and take necessary precautions. Examples of tides around the world. Bay of Fundy, Canada. The Bay of Fundy is famous for having the highest tidal range in the world, with water levels fluctuating by up to 16 meters. The dramatic rise and fall of the water here create powerful tidal bores and strong currents. Severn Estuary, UK. This estuary experiences some of the highest tides in Europe, with tidal ranges of up to 14 meters. The Severn bore is a large tidal wave that moves up the river during particularly high tides. Gulf of Mexico. In the Gulf of Mexico, diurnal tides occur, meaning there is typically only one high and one low tide per day. Tidal changes here are much less pronounced compared to areas like the Bay of Fundy. Bristol Channel, UK. The Bristol Channel experiences some of the largest tidal ranges in the world, second only to the Bay of Fundy. The tides here can reach up to 13 meters. Cook Inlet, Alaska. Cook Inlet in Alaska experiences extreme tides, with tidal ranges reaching up to 12 meters. The strong tidal currents create unique patterns in the water, and the dramatic rise and fall of the tides are vital for the region's fishing industry. Tides are the periodic rise and fall of sea levels caused by the combined effects of the gravitational forces exerted by the Moon, the Sun, and the rotation of Earth. The Moon, being closer to Earth, has the greatest influence on tides. As it orbits, the Moon's gravitational pull draws water toward it, creating a high tide. On the opposite side of Earth, a second high tide forms due to the inertia of water, while low tides occur in between these two bulges. There are two primary types of tides, spring tides and neap tides. Spring tides happen when the Sun, Moon, and Earth align during full or new moons, producing the strongest tides. Neap tides, on the other hand, occur when the Sun and Moon are at right angles, resulting in weaker tides. A few examples of extreme tides include the Bay of Fundy in Canada, where the tidal range can reach 16 meters, and the Severn Estuary in the UK, which experiences tidal ranges up to 14 meters. These tidal extremes not only affect coastal ecosystems but also have practical implications for navigation and energy production, as tides are increasingly being harnessed as a renewable energy source. Tides are one of the most visible and rhythmic natural phenomena on Earth. Caused by the combined gravitational forces of the Moon and the Sun, as well as Earth's movements, tides impact more than just water levels. They shape coastal ecosystems, influence maritime navigation, and offer potential solutions for renewable energy. Properly managed, tidal energy can be harnessed, and coastal risks can be mitigated. As tides have shaped life on Earth for millions of years, they will continue to play a vital role in both natural systems and human activities in the future.